My name is Sam Spallone, and I will be leading a 15-minute discussion with Dr. Russell Gersten of the Regional Educational Laboratory, or REL, Southeast at Florida State University. For at least a generation, educators have struggled with the issue of how to improve the performance of American students in mathematics on international assessments. The U.S. Department of Education has invested a good deal of money in professional development institutes to improve the teaching of mathematics, but do they work? Researchers at the REL Southeast recently published findings from a large-scale study of the effectiveness of a mathematics professional development. Russell, you and your team recently evaluated a math professional development program called DMI, which stands for Developing Mathematical Ideas. Why did you want to evaluate it?
This decision wasn't mine alone. It was worked jointly with the members of our research alliance. The RELs began about 6 years ago starting research alliances. Ours was set up around the idea of improving math performance in the states that were interested in involvement in this project. 3 states were Georgia, Florida, and South Carolina. And they really were concerned with fractions, with the National Math Panel report had come out recently and stressed the importance of fractions for leading to success in algebra. And they were trying out and have been, through these math science partnership grants, different professional development approaches. And so we're interested in, do they work? So I guess it was a dual series of questions. How can we improve fractions instruction in our state, and do these content-focused professional development efforts work?
What is content-based professional development?
Probably no 2 people would define it exactly the same way, but as I see it, it's basically the idea is to build understanding of the mathematical ideas that underlie arithmetic. That the theory would be, in order to understand that arithmetic is generalizations.
What is content-based professional development?
No 2 people would define it exactly the same way, but I think most would agree that the main idea is to teach mathematical ideas and principles to adults, but rather than going back to the chalkboard, PowerPoint, lecture approach with homework assignments and that kind of thing, to do this through showing adults that there are mathematical ideas and principles that underlie arithmetic, and showing this through a range of activities. And the theory then is that since algebra can be looked at as an extension of arithmetic, as a generalizable case of arithmetic, if teachers understood these ideas, such as commutativity, really understood the concepts related to a number line, that their students would then be in a much better position to understand algebra. It's also based on the approach that rather than training in methods only, teachers need to learn the math, that they have mathematical holes. Some of the research that Deborah Ball, Heather Hill, Leping Ma, and others have done has shown that there are holes compared to Chinese teachers, for example, in the mathematical knowledge that teachers have. And so the goal of content-based PD is to do this in a way that helps teachers learn the math, but also learn how it applies to the math that they're teaching their 2nd graders or 4th graders or 5th graders.
Is this possible?
We really don't know. Elegant arguments have been made, but we don't know if meeting this objective is possible. And that's why we did the study. Very few, up to this point, I believe there was only one rigorous evaluation done on this topic.
Was DMI the only program possible?
No, we were able to locate three potential programs. To be a program, ideally there would be evidence of prior research, but we knew there had been very little research done. So we looked for programs that had, seemed serious in terms of their thinking. It was thoughtful and the content fit. They covered fractions and depth. And we appointed a work group and they selected DMI based on a review of the materials and interviews with the developer.
Tell us a little bit about DMI.
It tries to reach the goal of building the knowledge of mathematical ideas and principles that underlie arithmetic by doing a couple of things. Let me start by what it doesn't do. This is what it doesn't do. It doesn't say, here is the commutative property. Let's see how it plays out in these addition and multiplication problems. It does not do that. It gives teachers pretty challenging problems that require them to articulate the commutative property, the distributive property, their understanding of what a fraction is and what equivalence is. So they have to use these to explain what they're doing and why they're doing it. So the goal is for them to develop these insights and to learn from their discussions and work with others. It also implicitly models the type of discourse-oriented math instruction that most of the states are pushing for.
Was this only about fractions?
Mainly. There were 8 3-hour lessons, and 6 of the 8 were fractions. Our target audience was 4th grade teachers. We picked 4th grade because that is the big year for fractions. 3rd grade's introductory material, 4th grade is fraction, concepts, ideas, some computation. 5th grade is more adding, dividing, that kind of thing. So we thought 4th grade would be the key year for this kind of work, where we get this kind of synergy. We're also hoping to get synergy in grade level teams. And so probably the material, 4 of the 8 lessons covered the 4th grade concept material, where the last 2 were kind of more advanced, covered what comes later in 5th or even 6th grade.
How intensive was this?
I'd probably say it was a moderate level of intensity. It focused consistently over a period typically of several months on one key topic with the same group of people who were using the same math curriculum and same district guidelines. And so the time commitment of 48 hours was decent.
What were they like?
Well, the 3-hour sessions, there were basically 3 parts to them. First, they began by looking at samples of student work that lasted about a half hour. Then they spent an hour discussing case studies from this case study book that everyone had a copy of that were taken from real life examples of teachers and what they were grappling with and how they grappled with students' misunderstandings. And then the second half of each session was essentially devoted to what I just described, solving these complex problems in groups, learning from each other, debriefing, facilitators circulated around.
Were there any follow-up classroom visits or coaching?
No, that's one reason I probably said this would be moderate intensity as opposed to high.
What type of study design was used to evaluate the DMI Math Professional Development Program?
This was a randomized control trial, so it would be what's often considered the gold standard. It took us a school year to complete all phases of data collection, and another year to analyze the data. We did this during the 2014-15 school year. We randomly assigned 84 schools in these 3 states to treatment and control conditions within each district. The 4th grade teachers in the experimental schools received DMI. The others didn't, to check what else was going on in the control group. We had all teachers, the DMI schools and the other schools, fill out a monthly PD survey where they talked about any math professional development they received.
What measures were used to assess impacts?
Okay, given our scale, we couldn't have hundreds of measures, so we focused on one key one for the kids and one for the teachers. For the kids, we actually developed, in conjunction with an IES research center on fractions, we developed a test called the TUF, the Test of Understanding Fractions. And this test came from items used by researchers, NAEP items, and items developed to accompany the Common Core standards. We created an item pool, had experts who were research mathematicians review these, so they were pretty carefully vetted for mathematical quality, and then we did our own psychometric analyses. So it seemed like a decent test that covered fraction concepts. I mean, some computations, minimal, and word problems, which are a critical way to see if kids understand concepts. Teachers, we used the item pool from the University of Michigan, the Learning Mathematics for Teaching Center, and we picked items, of course, related to fractions and the teaching of fractions. And these were developed from the item pool, and we then made sure psychometrically they were reliable and had the kind of range that one would like.
What were the key findings from the study?
I'll start with bad news. The kids who were in the schools with the teachers who had the DMI professional development did virtually identically well to the students in the control schools. I don't think I've ever found an effect size so incredibly low. It was 0 to, I believe it's the 2nd or 3rd decimal point was the effect size. Somewhat more positively, we don't know for sure that this isn't a chance finding, but in terms of the teacher's knowledge, we did have an impact of effect size of 0.19, and the probability level was 0.051. So had it been 0.049, it would have made the cut, so it just missed.
What about implementation? Was DMI implemented as intended?
I'd say moderate. I guess I'm using that word a lot here. We taped all the sessions, and then we randomly picked 2, one at the beginning, one at the end. And we had a protocol of what should be done that was developed by the folks at EDC. And the scores for the earlier lesson, 82%, second lesson, 78%. So hardly at this level, that one might get if you had grad students there who were having this aligned with their coursework and were observed weekly and monitored and all, but, a decent level.
Was there anything particularly weak in terms of implementation?
Yeah, I was real curious about that, and we looked at these data, and the part that seemed to fall apart the most was the time at the end where the facilitator is supposed to hook together what was going on in the groups she or he observed and pull together and have the group synthesize what they learned about division of fractions. What were the ideas there? What were the things that they'd remember and make sure their kids got? And that was often minimal. It wasn't clear some of the facilitators were able to do that as opposed to facilitate the learning activities.
Would you say this was a valid research study then? Aren't most research studies supposed to be implemented with high fidelity?
I'll tell you what current thinking is, and it makes a lot of sense to me, that there are kind of roughly two types of studies. One where things are done according to Hoyle. These are studies where you see, can this professional development program accomplish its goals? When you have the grad students doing it or the folks who are veterans doing it, they're monitored all the time to make sure they're doing all the steps and there's corrective feedback if steps are missed. That's one kind of thing, and that's well and good. And in this area of professional development, too little of that has been done, perhaps. But the other type is where you look at what happens in the real world of schools. Now, it's not like you look at any old piece of junk or anything. This was far from the case. This would be what a very conscientious implementation of DMI would be. All of the facilitators were trained by EDC, the firm that developed the product. They were given a kind of retraining, what would you call it, a bootstrap session right before they began in the fall. They were handpicked by the developer. Of course, they had to be available for the days the schools needed them. So the release time was covered by the research project or compensation for working Saturdays. So that was, a little different than typical. And this would be very much what if a city like Atlanta or Macon just decided they wanted to have a professional development program like this, what they might do with a university or a firm, that you get trained people and they come and they follow the protocol, they follow the protocol basically. And so it's very important to see, because this is what you're going to get if you use anything at scale in schools.
Have any other studies found similar results, or is this an anomaly?
There were actually two studies coincidentally being conducted at the same time, one by Robin Jacob and colleagues, and the other by Mike Garrett and his colleagues, and they found very similar results. Theirs were a bit maybe better funded studies, so they also were able to observe instructional practices, but they were done right about the same time. They found impacts on teachers' knowledge measured different ways. I know Mike Garrett's study found one aspect of teaching practice, something related to errors made, fewer errors were made, mathematical errors were made, and there was a bit more precision, I believe, in the teachers who received DMI. In his case, it was Intel Math. But basically, all three of these content-based PD programs did not lead to any improvement in student performance.
What's the takeaway message for the practitioners and policymakers?
This is a time I can be a little bit speculative. These are possible messages, and different people may take different things back from this. First is that this takes a long time to gel in people, and a year isn't enough. And I consider that, but we've heard it before. I'm not as sure. I know one study was done over 2 years and one over several years, and I'm not sure about that one, but that is one that some will mention. One that hit me very hard was that this one-size-fits-all kind of thing that we'll do didn't seem to work very well. Observing these lessons, you'd see that, especially during the activities, that some people, they were working as intended. By having to explain and listening to others explain or misexplain and them clarifying, they were really developing deeper insight into the language of math, into the ideas that go on when you divide two fractions or determine why two fractions are not equivalent, or determine where to place them on a number line relative to each other given limited knowledge. Others seemed lost a lot. We went back and looked at the pre-test scores of the teachers on the math knowledge measure, and there was a huge range. So I would say this approach is not so good. Now, another approach used in summer institutes is the people who love math and often are pretty good at it attend, and the others don't. The problem for that as a district investment is, if you want to have math people who departmentalize and specialize in math, then that's fine. But if not, the problems are going to fester. But it's something worth thinking about. Also, the pace seemed kind of rushed, and I don't know if that's true here. That's something we go through in college teaching. We go through in elementary teaching. We go through in every kind of professional development. How much to cover, breadth versus depth. Don't have an easy answer to it, but here it seemed to go too fast. I wonder if all 8 lessons were devoted to the 4th grade fractions content, that the impact may have been felt more. Some of the teachers felt that too, that they really wanted the stuff to focus all the time on 4th grade, because it is complex material. There's a lot of it in just the fractions units. And the other thing is, I'm sure you were implying, Sam, there was no coaching or follow-up, and that could be an issue here for sure. Tied into that was an even deeper problem with DMI, and I don't know how true or not true it is for these other approaches, is that teachers did not have either sample lessons, like for example the AMSTI project in Alabama has sample science lessons that you can literally kind of rent from their website or however they do it, and use them with your kids and get some technical support in using it. So they had to devise everything on their own. There was no adaptation guide for how to adapt their textbook lessons or anything. So that is, I think, an important takeaway. So I think all of them are important takeaways.
Thank you, Dr. Gersten.
This recording was created by the Regional Educational Laboratory Southeast at Florida State University. Information and materials for this recording are supported by IES/NCEE's Regional Educational Laboratory Southeast at Florida State University, contract ED-IES-17-C-0011, as resources and examples for the listener's convenience. Their inclusion is not intended as an endorsement by the Regional Educational Laboratory Southeast or its funding source, the Institute of Education Sciences. In addition, the instructional practices and assessments discussed in this recording are not intended to mandate, direct, or control a state's, local educational agencies, or schools' specific instructional content, academic achievement system and assessments, curriculum, or program of instruction. State and local programs may use any instructional content, achievement system and assessments, curriculum, or program of instruction they wish.